Hello, so in this video, I want to talk about the packet tracer assignment. This is packet tracer IP and network applications. So in this topology scenario, you will notice that this should look somewhat familiar in that we've used this in other packet tracer labs. But let me mention a few things. So this router here, router 0, it has actually been pre-configured with its IP addressing, has an IPv4 address, also has an IPv6 global unicast address and IPv6 link local address. I'll come back to that in a moment, and has a MAC address on its NIC card. This interface here, gigabit 00. On its other interface, gigabit 001, it also has an IPv4 address, an IPv6 global unicast, link local, and MAC address. So this router has been all pre-configured for us, and I'll talk more about that in a moment. Other things that I want to mention here in this lab, what we're going to be doing here is we have these client PCs right here, okay? So they're going to be getting their IPv4 addressing information from DHCP-v4 server. We're going to be configuring this device here as a DHCP-v4 server. I'll talk about the IPv6 addressing information a little later. We're also going to be configuring this server here as something known as a DNS server, because it is when the PCs, the clients, do something like www.ric.com, looking for the IP address associated with that domain name, they will ask their DNS server, this device right here. We'll see how that works in a moment. So where is that web server? Well, that's over here. We're going to be configuring server 0 as a web server. So by the end of this lab, what you will be doing is you will configure this device here as a DHCP server, a DNS server, and a DNS server, and this server here as a web server. And these devices here will get their addressing, their IPv4 addressing from the DHCP-v4 server. They'll get their IPv6 addressing, as we'll see, from the router. Wow, that's different. But they're going to be able to type in a URL, whatever you decide you want to call your web domain. Maybe it's www.ric.com over here. So you'll be able to type that into a browser. It will get the IP address associated with that from the server. It will return the IP address, and then you'll be able to get the web page. Yes, so just like a real network. So let's get started. All right, so the first thing I want to kind of go over is let's take a look at the IP addressing on one of these clients like PC0. Okay, so I'm going to go here to desktop, command prompt, and I'm going to do IP config, and I'm going to do actually /all. So that's going to show us some extra information I want to share with you. Okay. So first of all, notice its IPv4 address. It says auto configuration, IP address, that's IPv4. Whenever you see an address starting with 169, that's a problem. That means that the device has been configured to obtain its IPv4 addressing automatically, which most clients do by default. However, when it sent out a request to look for a DHCP-v4 server, saying basically whoever out there is a DHCP-v4 server, send me your IP address information. So it sends that out. No one responded. So this PC didn't know what to do. So it gave itself this address right here. It basically means it does not have any IP addressing configuration. We can see it does not have an IPv4 default gateway or an IPv4 DNS server address. Okay, it did give itself this subnet mask, but that's neither here nor there, not that important. Okay, so we're going to fix that. Actually, let's start with that. Let's get that fixed right now. So let's go to this server here, server 1. And I'm going to expand this. Server 1, by the way, if I go over here to config, you'll notice in Fast Ethernet 0, it has a static IPv4 address, subnet mask, even a static address for its default gateway. This is what we do with servers. We give them static addresses. Okay, so I'm going to go over here to services, and we can see all these different network application services, some of which we've talked about in class. Okay, but I'm going to go over here to DHCP because this has been for DHCP for IPv4. And we can see it, Packet Tracer already has what they call a server pool. So let's take a look at what this is. First of all, the pool is off. We're going to enable this as on here in a moment before we finish. But let's get a few things configured first. The first thing it says is, what is the starting IP address we want to begin with? That's right here. So the first device, what address should we give it? Well, we usually want to make this something higher than, 1 or 2. We want to give, because the first few addresses, like the router is 192.168.1, this server is 192.168.1.50. So we don't want this so that's the address of this server, remember? 192.168.1.50. We don't want this DHCP server to be giving out addresses that we've configured statically on other devices. So let's have it start at 100. The subnet mask, yes, 255, 255, 255.0. We're happy with that. What else? Oh, the default gateway. Let's change that because that's going to be our router's address right here. Okay, 192.168.1.1. So we want to tell the devices that's your default gateway. DNS server. That's going to be actually this device, the address of this same server, because it's actually wearing 2 hats, DHCP server and a DNS server. Okay. What else? Maximum number of users. We're going to say the maximum number of users we're going to have is 100. Okay. All right. So I look at all of this here. I'm just going to click save to save this information. And actually, if I expand this, you'll see this information down here updated. There we go. Save. Now, there's one more thing we need to do. This service is off by default. So let's go ahead and turn it on. There we go. Okay, well, we may see some changes here. Let's go ahead and go to the client computer, back to the client. Okay, sometimes it takes a moment, but let's go ahead. I'm going to do ipconfig space/all. Notice that it still does not have its address. Now, let me show you how you can do this in Windows, although it doesn't typically work in Packet Tracer. But if I was on a Windows prompt, I can do ipconfig/release and then ipconfig/renew, meaning release my current IP addressing configuration. And when I do renew here, it's going to send out that message. Hey, everybody out there, who's a DHCP v4 server, send me IP addressing information. That's exactly what it just did. So it said, hey, who out there's a DHCP v4 server, send me addressing information. This server we just configured responded, okay, and said, here you go, and gave it, looks like it started at 103. Why is that? Probably the other clients we have already asked for their addresses. We'll see that in a moment. But no, so it received, let me use a different color here so you can kind of see that a little better here. So here's the address, the IPv4 address. Okay, so it looks like probably a couple of other clients got the 100, 101, and 102. Here's the subnet mask that we told it to get. Here's the default gateway that we told it to get. And here's the DNS server address. Okay. Matter of fact, if I do ipconfig/all now, we should see all that information. Yes, there, that looks better. IPv4 address, subnet mask, okay. And here's the server it got the information from, the DHCP v4 server. Here's the DNS server it will use. We'll use that in a moment. Oh, and the default gateway, can't forget that. So it's got all that from the DHCP v4 server. Okay. All right. Now I want to talk a little bit, though, about the IPv6 addressing information, because we didn't do anything for IPv6. It has, it already has an IPv6 address. This is a global unicast address. The first 4 hextats, 2001, DB8 to CAD1, that's the network portion. So all the devices will have that as their network portion. And here's its unique IP interface or ID or host portion of the address. This is the default gateway. This is actually the link local address, of this router. So that's where it's going to send it to. So typically we use link local addresses that are only good for this network. That's this address here, the router is only good for this network. We usually use that as the default gateway. I'm going to explain in a moment how all this happened, because we didn't do anything, did we? This is the amazing part of IPv6, or one of the amazing things. Okay, some other things I want to mention. Also has a DNS server address. How did it get all this? So let me explain something. So one of the big differences with IPv6 is by default, router will send out something called an router advertisement message. Okay, this is actually part of something called ICMPv6. And it sends it out as the source address of this router advertisement is actually this link local address. That's the source IPv6 address of this router advertisement message. The destination address, well, it's something we call a multicast. It's for all IPv6 devices. So that's basically all of our devices. So all these devices are going to get this router advertisement message. Let me explain what's in this router advertisement message. Very cool. First of all, once again, this was the source address of the message. That's going to tell these devices, hey, use this address, FE80:1 as your default gateway. The other thing that's very cool is it sends out this portion, that network portion of the address, of its addresses. This is the network you belong to. So everybody out here, this is your network. You can create your own interface ID, your own host portion. Do that yourself. And by the way, one other thing I'm going to include in this router advertisement, here's the address of the DNS server. So it includes the in the advertisement, the message it sends out, it actually includes the router it includes the address of the DNS server. So, and actually I can show you that too. I'll show you that in a moment. So that's how these devices got all this information, like PC0. It got this from the router advertisement message. It says that's the network I belong to, and it created its own interface ID. And it gives itself a /64 prefix length subnet mask. The default gateway address, that was just the source IPv6 address of the router advertisement. It says, oh, that's where it came from. You're my way out of here. And this was also in the router advertisement message. Matter of fact, let me see if I can show you this real quick here. See if it comes up. Cisco enable class. Okay, I'm going to do debug IPv6 ND. This might take a moment, maybe not, but it will actually show us. Ah, there we go. That was on another interface that's going out. We'll just wait a moment, see if it shows us the other one. These router advertisement messages are sent out every 200 seconds. See if we can get one going out the other interface here shortly. I'll just move this over here. But let me just mention something while we're waiting on that. So what you might have noticed is these computers here never needed a DHCP server. The router will give them their IP addressing information automatically. All righty, let me stop here. I think I saw it come. Here, I'm going to clear this out. Yeah, let's take a look here. You don't have to worry about this for any test, but I do want to show it to you. So this is the router sending out its router advertisement message. It says, this is the network you're on. It says, create your own address. Okay. Now, one of the things it's not showing is the address of the DNS server, which that's a bug, and I need to report that. And this is it's saying, hey, use me as your default gateway address. Okay, enough of that. But anyway, where IPv4, in IPv4, these devices require the services of a DHCP server for addressing information that's not required for IPv6. The router just says, this is what network you're on, and here's some other information that you're good to go. Now, at home, your home router acts as a DHCP server for IPv4. So when I say you don't need, the router does everything for IPv6, it's your router at home acting as a DHCP v4 server. Okay. All right. Let's take a look at a few other things. So we've handled that. Okay. So it looks like we should have all of our addressing information. Matter of fact, if I click on one of these other computers, clients, let me go here, desktop, command prompt, should see similar information. I can spell. There we go. So I'm over here at PC3 right there. And we can see, yeah, there's IPv4 address got from the DHCP v4 server, subnet mask, default gateway, IPv4, and there's the DNS server IPv4 address. And of course, IPv6. There we go. Hey, I got that from the router advertisement. I created my own host portion, interface ID. I got this from the router advertisement, my default gateway, and I got the DNS server address also from the router advertisement. I never needed a DHCP server for IPv6. Very cool. All right, let's continue here. Next thing I want to do is I want to go over here and configure server 0 as my web server. So again, it already has IP addressing information. So we're just going to go over here to HTTP. Okay, and let me expand this a little bit. And what I'm going to do is go over here where it's index. Okay. And what I'm going to do is go ahead and I'm going to select index HTML and click edit. Okay, so this is a little HTML. It's already something here for you. It says, welcome to Cisco Packet Tracer, opening doors for new opportunities, mind wide open. Okay, and if you know a little HTML, you can actually do whatever you want in here, but I got to make this really easy. I'm just going to replace this header where it says, welcome to Cisco Packet Tracer, and I'm going to actually just say, welcome to Rick's Surf Shop. Maybe someday. No, I'd rather go into my friend's surf shops. Welcome to Rick's Surf Shop. I will make it surf and skate. Why not? Shop. All right. So that's all I've changed. I'm going to just do save here, but just to show you I've made a change. Okay, click save. Yes, I want to overwrite. All right, that's my web server right there. Okay. And make sure, by the way, make sure that you click save. So after you do edit, save, and make another change here just so you can see it. Save, I'll do 3 exclamation points. How's that? Save. Yes. Okay. So make sure you save. All right. Let me go ahead and close this now. And I clicked yes after it asked me. Okay, next thing I want to do is go to my DNS server. Well, we haven't configured, but go to my server right here, server 1. And what we're going to do is configure a DNS server. Okay, so we can go over here, find DNS. Now, what I'm going to do here is create a DNS record. Okay, this is an A record. You see we have A and quad A records. A record is for IPv4, quad A is for IPv6. What is an A record or quad A record? Well, let me show you. It is basically where your DNS server, we'll be talking about DNS if we haven't already, but a DNS server either has this information or obtains this information from another DNS server. We'll learn about that later. What information is that? It's this information right here. I have registered www.ricksurfshop.com. Okay. And the address is associated, and it's with this server right here. See this IP address right here? This is the server where we have our website. It would be a public IPv4 address. Now we'll learn about CDNs and cloud and some other things, how they do this now on most sites nowadays, but it is a public IPv4 address. Okay. In this case here, it's a specific IPv4 address. We have it specifically on that server. So I'm going to type in 10.0.0.99. Yeah. And what I'm going to do is click add. And I could add multiple domain names and different IP addresses or same IP address if it's on this device. Notice it says A record. If I wanted to do a quad A record, meaning I want to get there via IPv6, I would do something similar. I'd actually give it the same name. I wonder if I can copy that. There we go. No. Let me say quad A record. Oh, there we go. Probably not the best, but I wanted to try to copy ricksurfshop.com. And here I'd give it the IPv6 address of this server right here. The global unicast address, because it's got to be accessible from the internet. Any place on the internet, a CAD. Okay, and I'll add that. So you can see I have actually 2 records. Same website. One's an A record for IPv4 and one's a quad A record for IPv6. Why do they call IPv6 a quad A record? Well, that's because we use 32 bits for IPv4 and 4 times 32 is 128 bits. So somebody decided, let's call it quad A. All right, let's do this now. We got to verify. So that was our DNS server right here that we configured. So what we're going to do now is I'm going to go to PC0 here. First of all, let's make sure we have communications with what we need communications for. Okay. Can I ping my default gateway? So if you remember our default gateway, and we'll stick with IPv4 here, default gateway is 192.168.1.1. Can I even get out of my own network? Yes. Can I ping the address of my DNS server? My DNS server is 192.168.1.50. Matter of fact, I have that right here. DNS server 192.168.1.50. Can I communicate with that device? Yes. Can I even communicate via IP with server 0 over here? Let's try that. Ping 10.0.0.99. Okay. Rick didn't panic when he saw this request timeout because either PC0 had to do an ARP request to get the MAC address of the default gateway, or maybe the router had to do an ARP request to get the MAC address of server 0. Okay, but it's not uncommon to see the first one or two pings time out. Okay, something else I can do to make sure that I'm actually getting, when I want to connect to www.rick, did I say Rick Surf Shop or Rick Surf Shop? I don't even remember. Better check my DNS server, huh? Let's see, DNS. I've called it Rick Surf Shop. Okay, you see right there, Rick Surf Shop. All right. All right, to make sure that I'm communicating with the DNS server, I can try pinging. Now, this isn't pinging the DNS server. I want to ping this web server, but instead of using the IP address, I want to use the domain name. That didn't work. Well, let's go back and take a look. What's going on here? Let me actually close this. I'm going to go to my DNS server. Somehow it didn't resolve. Why is that? Okay, I want to show you. So here I use domain name. That didn't work, but I can ping it. So I know I can reach that device. And I know I can reach the DNS server. Let's go back to the DNS server because Rick forgot to do something. I love troubleshooting because we learn more when things go wrong than when they go right. So what looks wrong here? Look, I forgot to turn the service on. Okay, so by default, Packet Tracer has this service disabled. Okay, now let's take a look. Okay, so let me try pinging that again. There we go. I can now reach it. Oh, it's using IPv6 by default. Good Packet Tracer. You know, when you're running both IPv4 and IPv6 on your computer, like if you have Comcast, like Rick does at home, it will use IPv6 by default. Interesting. Okay, so let's do this though. Now, this is what we want to make sure everything's working, right? Going to close this. Go to web browser. Type in www.ricksurfshop.com. Click go. Welcome to Rick Surf and Skate Shop. Okay. So PC0 obtained the IPv4 address and IPv6 address for www.ricksurfshop.com from this DNS server. It returned the IPv4 and IPv6 addresses of server 0, 10.0.0.99 and 2.0.0.1 DB8 CAD2 :100. And now so it's able to communicate via IPv4 or IPv6. And it looks like it's used IPv6 by default because that's what it will do. And it gets the web page and displays it. So now you have a real working network. All right, I hope this made sense and helped you and was a little fun for you. Shows you how much you've learned. All right, thanks a lot.